All right, we're going to take a look today, instead of just working within another base system, which is kind of what we looked at last time, so we looked at the number before, the number after, and base whatever, we're going to actually do what we did with our Babylonian friends and our Mayan friends and whatever, and we're going to actually do some conversions today. Now, you'll notice that part of my instructions here, I have a strike-through. The instructions in your book say what this says, but without the strike-through. They say convert each number to decimal form by expanding in powers and by using the calculator shortcut. I'm not going to teach you the calculator shortcut. You're welcome to learn it, but I want to see the expanding in bases part of this. That's important because that's a conceptual understanding of what's going on. Calculator shortcut, if you want to do that or learn that to verify your answers, fabulous, go for it. But you don't have to do that as part of your homework, okay? All right, so what I want to show you is I want to show you how this works in whatever base we're working in. Actually, before I start, Jonathan and I were having a really good conversation after class last time because I think I was kind of a little bit mean to him unintentionally when he asked a question in class, and I need to apologize to you guys for that because I get this sometimes, right? When are we going to use this? And in our conversation, I remembered that there's several other cases besides the base 2, base 16 we were talking about. He and I were talking, and there's actually two other really good points or really good examples of, I don't know, modified maybe other bases that you use all the time. One of them is the clock. What base is used on the clock? Base 12, at least in terms of our number of hours, right? We use base 12. And even if you don't use base 12, if you want to go military time and use base 24, you can do that too. Because it all starts over again at the number 1, and we have this sort of a base system. So you do use a base 12 variation when you talk about time. You could also talk about it in terms of being almost like a base 60 if you're talking about minutes and seconds, can't you? Yeah, kind of like those Babylonians, right? Base 60. Another example is, again, this isn't exact, but it is similar. And I've done this example with coins in class before. If I were to give you a bag of coins and there were pennies, nickels, and quarters in it, that would be an example of base 5, right? 5 pennies makes a nickel, so we would never give change and give you 5 pennies, would I? Not unless you were out of nickels, right? I mean, you wouldn't do that. And I wouldn't give you, again, ignore dimes and ignore half dollars and that stuff, okay? So ignore those. That's not in the bag I'm giving you. I've only got I've only got quarters and nickels and pennies. So I wouldn't give you 5 nickels either, right? There's this idea that when you make change for someone, you want to give them back as few coins as possible, kind of an idea. Same thing. So that's actually a modified base 5 system that we use when we do our money. Like I said, we've actually got dimes and we have dollar bills and things like that too. So it's not exactly base 5, but there is a base 5 component in what's going on there. So there's a couple other real life examples, and I'm going to show you another kind of example when we work the other direction in a moment here. But here's what I want to show you on these. All right, so we have a base 2 system. Okay, so just like in our base 10 system, every place value is a power of 10, right? This is yes. Base 10, powers of 10. That's what our place values are. We have 10 squared, that's the hundreds place. We have 10 cubed, that's the thousands place. And that's what we call them, right? They're all powers of 10. Well, these are powers of 2. So I'm just going to write them out a little bit more so that I have more space because I don't have enough space to write. These are all different places, place values. The first place is always the ones place. It's actually whatever the power is to the number 0, or whatever the base is to the number 0, but anything to the number 0 is 1. So this is the ones place. The next place is the base that you're working in. So this is base 2, so this is the 2's place. And then after I've established those, everything else is a power of 2, because that's my base. So this is the 2 squared's place. This is the 2 cubes place. And if we had more, we'd have 2 to the 4th and 2 to the 5th and so on. Okay? Now, let's pause for a moment and write down what these numbers really are. What is 2 cubed? That is 8. What is 2 squared? That's 4. So the way that we turn this back into our number is we take each of the place values times the value that's in its place. That is, we take the number 1 times 8. We add to that the number 0 times 4, because that's its place value. I know it's 0, but I need to hold it just so you see. Then we take the number 1 times its place value 2. And the last number 1 times its place value of 1. all this is multiplication and addition, right? There's a fly on my head. Okay, sorry. All right, somebody grab a calculator or do it in your head really quickly or whatever, and somebody tell me what's 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1. Is it 11? Awesome. All right, so this is the number 11. Somebody did in their head really fast. Okay, number 4 looks funny because I don't see any numbers. Do you? Not exactly. We did talk about this sort of in passing last time. This is your hexadecimal, right, Glenn? Yeah. And we talked about the fact that at least your book, and not every book does this, but your book uses the alphabet letters in order. So A is the number, do you remember? 10, and B is the number 11, and so forth. So this actually is the number, this number A is actually the number 10. The number B is the number 11. What's the number C? It's the number 12. And then D would be 13. Okay, so these are the values in the placeholders. These aren't the placeholders themselves. Okay, so I'm going to put the values above and put the placeholder values below. Okay, so this is base 16. So this is the ones place. And then what comes next? 16. It's always the base, whatever it is. The next one would be 16 squared, which we'll find that in a minute. And then the next one would be 16 cubed. All right, so somebody's going to grab a calculator or really do something amazing in their head and tell me what 16 cubed is. You don't know it in your head? Oh, somebody had one. Okay, what was it, Tyler? 1,096. 4,096. Okay, how about 16 squared? 256. Okie dokie. So I take the place value, or the value in the place, which is 10, times the place value, which is 4096. I take the 11 times its place value, which is 256. I take my 12 times its place value, which is 16. And then I take my 13, technically times its place value, which is 1. And I suspect you'll want to grab a calculator, because this is a rather large number with a lot of multiplication and addition, not just like the 2's we had above, right? What do you get? $43,981. So ABCD base 16 is 43,981 in our base 10. Is that okay?
Shouldn't it be bigger than that?
Why would it be bigger than that? I mean, what do you want it to be bigger?
Well, I mean, 10 times 1,000 is already...
Yeah, so it's 40,000, right?
Yeah. So then... Oh, never mind.
It just felt like it should be bigger is what you're feeling like. Yeah, it's okay. This is correct. This is what I have written down, so Tyler and I got the same thing. But it's good to do what you just did, Adam, which is to look at it and say, does that make sense? And I want you to notice one thing that's interesting here. So base 16 is a bigger base than our base, right? 16 is a bigger base. And if you compare this ABCD with our 43,981, which one has more numerals? Yeah, the 43,000, the one we got at the end, right? The smaller base has more numerals, doesn't it? Look at it. It works up here, too. Okay, I do. There's a fly. Okay, this is base 2. How many numerals? 4 of them, right? 4 numerals when I've got this base 2 number. This one right here is our number in base 10. And how many numerals does it have? 2 numerals. So this is not just by accident. Smaller base, you have more numerals. And if you have a bigger base, you have fewer numerals. So it's a good thing to check and make sure at the end that you didn't do something backwards and end up doing something wrong. And we'll do a couple others now. We're actually going to take now a number in our base and turn it into, in this case, base 4. So this is going to look like what we did with the Babylonians and the Mayans on the back of that quiz you just got, which is one of the reasons I wanted to go over it before we got here today. Remember what we did? We did this sort of a division thing, right? And it went down and we divided by a bunch of stuff. We're going to do that again, but we need to know what we're going to divide by. And it's all based on what base you're in. This is base 4. So what I need to do is I need to figure out what my placeholder values are in base 4. Well, I know I've got a 1's place, and I know I've got a 4's place. And I know from what we've done in the last page here, or slide here, I've got a 4 squared. What is 4 squared? Good, 16. I know I could do 4 cubed. What is 4 cubed? That is 64. What is 4 to the 4th? 256. I'm running out of space. Let's see if one more is enough. I'm not sure. What's 4 to the 5th? 1024? All right. Yep, I'm out of space. Okay, let's see if I can move this down just a second. Okay. How about 4 to the, what is next? 6. 4 to the 6th. 4,000, is it 96?
Yes.
Okay. What's 4 to the 7th? 16,384?
Yep.
Okay. I know that I've got too many of them now. What's wrong? How do I know I've gotten too large?
There's only 5 places.
Yeah. I've gotten above the number I'm dividing by, right? I only need a number that's as big as 11,028. So this one I won't need. It's too big. Just like when we were doing the Babylonians and we got something that was too big, we don't use it to divide by then. So I'm going to end up dividing by each of these numbers. So I'm going to divide 7 times, aren't I? Okay, is everybody with me? Okay, does everyone have these written down? Because I'm going to need more space, and in order to do this, I think I'm going to have to erase these guys. Let me see if I have more space over here. Nope, I don't. Okay, can I erase them? Okay. All right, so the farthest I went was the number 4,096, wasn't it? So I'm going to take 4,096, and I'm going to use that to divide 11,028. And how many times will 4,096 go into 11,028? Twice? Okay. What is 2 times 4096? 8192. And then we subtract. What is 11,028 minus 8192? 2836. What's my next place value? 1024. So how many times will 1024 go into 2836? Twice. It will. So either in your calculator or in your head, you're going to multiply 2 times 1024. I can do that one in my head. 2048. And then it's 788. Okay. All right. What's my next place value? 256. How many times will 256 go into 788? 3 times. What is 3 times 256? Ooh, that's nice. Because when I subtract, I don't get much. What's left over? 20. Be careful. I still need to represent the other divisions. What's the next power after 256? 64. Will 64 divide 20? No, but I need the 0 placeholder there. So please make sure you're putting it. This is the easiest way to not forget it. So I have 0. I've still got a remainder of 20. What's my next place value? 16. 16 goes into 20 once. and I do 16, what's my remainder? 4. Okay, so I'm out of space. Yours would continue. The next place value is actually 4, and it goes in once, so I've got a 4. This is 0, but I'm not done. I still need to divide by 1, and of course I'm not going to get anything because I'm done dividing, but I need that 0 on the end. My answer is right here. All of those numbers. Two, 110. Hang on. I don't have enough space and I need it, so let me move this over just a bit. What's missing? Do you know? Yeah, the base 4. The little subscript that doesn't look like a 4, but pretend. All right, so 4 is a smaller base, and I have more digits, don't I? Yes. Here's something else I want you to notice. Notice all of everything I circled in yellow there. I've got 1s, 2s, 3s, and 0s. Could I have had 4s or 5s or 6s? No. How come? Because this is base 4. So if ever you're dividing and you divide something and you end up getting a 6, that should be a red flag. Oh my goodness, I can't get a 6. This is base 4. There's no 6s in base 4, right? It means I made some error and I need to go find it. Okay, we're going to try another one. 99,999 in base 9, and there are no 9s in base 9, right? No. But I won't have quite as many digits as I did before because base 9 is not a lot smaller than base 10, is it? No, not like when I did 1 at 10 and 4. Okay, so I have to write down first all the place values. So I've got the 1's place, I've got the 9's place. The next one's 9 squared. What's 9 squared? 81. How about 9 cubed? 729. Okay. How about 9 to the 4th? 65, 61. How about 9 to the 5th? Okay. That's a 9. And I need to somehow separate this. Okay. It's supposed to be a 9. It doesn't look very good, I agree. I'm not sure that's any better, but pretend it says a 9. All right. I could do 9 to the 6th if you'd like, but it's going to get very, very too large because I'm already at 59,000 and the number I'm dividing is 99,000. So I'm certain that I'm done. But if you test 9 to the 6th, you could see.
59,040 what?
9. Yeah, 59, 0, 49. I'll just do it again. Oh, it's readable. Okay, so we're going to divide. We're starting with the highest base. That is the highest place value, 59, 0, 49. And we divide 99,999. And how many times will that go in? Ones, right? So I'm going to subtract 59,049. And when I subtract, what do I get? 40,940. Then what will I divide by? What was it?
That's 50. 9 minus 40 is not.
Oh, I'm sorry. I just heard you guys wrong. I'm sorry. Let me fix that. Thank you. Perfect. Okay, now what will I divide by?
6,561.
Okay. There's a fly. Okay, 65, 61. How many times will 65, 61 go into 4950? 40,950.
6 times.
6 times, okay. And then what is 6 times 65, 61?
39,
366?
Yeah.
Okay. All right, so what's 40,950 minus 39,366? Okay, I feel like I must have heard wrong.
No,
Yeah.
1584.
1584? Okay, did that work? Okay. Next place value, 729, right? How many times will 729 go into 1584? Twice. What is 2 times 729? 1458. And then what is 1584 minus 1458? Okay. 126. What am I going to divide by next? 81. How many times will 81 go into 126? Once. I can do that multiplication in my head. That gives me a remainder of what? 45. What will I divide by? 9. How many times will 9 go into 45? 5. We're getting good practice with our multiplication and division skills today, right? This is 45. Which I have a remainder of 0 now, but I need to be representing the fact that I still need to divide by the number 1, and I don't get anything, but that 0 on the end is part of my number, so I need to make sure it's present. So my answer is 162,150 base 9. Smaller base, and there are more digits, aren't there? Yeah, I have 6 digits as opposed to 5. I started out with 5 digits. Okay, is everybody with me on this? Mark.
I'm just curious, like, would you put commas in that or no?
You can if you want, but the base 10 convention of the commas is kind of where that came into play. It's kind of like, putting the commas in the middle of the Babylonians or whatever. That's sort of not accepted practice. If you did, it's not going to be a big deal. But I know as much as anything, our commas sort of help us keep track of the number of digits we have, right? And so if you wanted to put them in, it wouldn't hurt anything. Yeah. Okay, what is different about example number 7?
More work,
It's more, somebody says more work. Why is it more work?
just to convert it and then convert it again.
Yes. And I think somebody else was already saying that. It's changing between bases, right? And Adam's exactly right on how we're going to do that. Well, the way we do this is what we're going to do is we're going to take base 5, and we're going to convert it into base 10, and then we're going to take base 10 and convert it into base 7. Okay? So this is a 2-step problem. It's got both of the last 2 different slide components, basically, the multiplication component and the division component, both present. Okay? So thinking about your test next week, you need to write down on the card, or you need to make sure you know when you multiply and when you divide. Okay? So moving from base 5 into base 10, do you multiply or do you divide? You multiply. You multiply. So when we move into base 10, no matter what the base was to begin with, whether it was bigger or smaller than our base, when we move into our base, we multiply. And then when we take our base and move it into something else, we divide. So we're going to multiply to get 43, base 5 into base 10. All right, so here's 4, here's 3. They're in base 5, which means this is worth 1 and this is worth 5. Everybody with me? Okay, so how do we turn that into our number? Multiply. We multiply the number 4 times its place value, which is 5, and the number 3 times its place value, which is 1. And what do you get? 23. Now, you might pause and say, 23 is base 10 rather, is a bigger base. Shouldn't I have a smaller number? And the answer is yes. But if you compare what the numbers look like, it does appear smaller. I don't have fewer digits, but it does appear smaller. It appeared as 4-3 earlier, and now it appears as 2-3. Right? The number looks like a smaller number. It doesn't have fewer digits, right? Sort of by default, because I'm dealing with a real small number to begin with. But it does have a smaller look to it. Now I'm going to take this 23, and this is base 10, if you want to write the 10 just to remind yourself you're not done or whatever. And I need to turn it into base 7. And so in order to turn our number into another base, we divide. All right, we divide by powers of 7. So we have the 1's place, we have the 7's place, and then we would have 7 squared. What's 7 squared? 49, and that is too big. I don't have 49, I only have 23. So I'm going to go back to the 7. I will need to divide by the number 7. How many times does 7 go into 23? 3 times. And 3 times 7 is 21, and 23 minus 21 is 2. How many times will the number 1 go into the number 2? 2 times. So this is my solution here. 3, 2, base 7. It's got to have the base 7 next to it. Okay? I think I have one more like this. It's looking like it. It's base 2, isn't it? There's a lot of digits. I'm tired already looking at it, aren't you? The nice thing about base 2 is that base 2 has only 1's and 0's. So the multiplication component with base 2 is really nice. So I'm taking from base 2 into base 10, back into 8. How do I go in from 2 to 10? I multiply. From 10 to 8, I divide. All right, so these are powers of 2, and I'm just going to count. I've got, oh dear, well, I think I'm going to have to spread it out because I don't think I can do it. 1, 1, 0, 1, 0, 1, 1, 1, 1, 0, 1. Did I get them all? I think I did. This is the 1's place. This is the 2's place. What comes next? 2 squared, which is 4, right? What comes next? Which is 8. What comes next? 2 to the 4th, which is not 16. Oh no, it is 16. Sorry, I'm one more on. I was already thinking on 2 to the 5th. Let's go there. 2 to the 5th is 32. There we go. The next one's 2 to the 6th. What's that one? 64. Good. 2 to the 7th? 128. 2 to the 8th? 256. 2 to the 9th? We're almost done, 512. And then 2 to the 10th? Awesome. So let me first say that all the ones that have zeros in them don't count, do they? I mean, not really, right? Because when you multiply by 0, you get nothing. So I really need to add up the ones with 1's in them. And when I multiply by 1, it's also really nice because what happens when you multiply by 1? It's just the other number. So I really have 1024 here, 512, 128, 32, 16, 8, 4, and 1. What is that? Okay, 1,725. And you don't have to write the 10 I am just to remind us that we're not done. I need to put this now into base 8, which means I need to know what are my powers of 8. And I got to change colors because we've got too much yellow and white on my screen. Let's try that one. So I have the first place is the 1's place in base 8. The second place is 8, right? The third one is 8 squared. What's 8 squared? 64, good. The next one is 8 cubed. What's 8 cubed? 512. Sorry, I'm running into my words. It's 512. One more up here I think is enough. 8 to the 4th is 1,096. Awesome. 4,096, okay. And 4,096 is too big, right? Okay, so I don't end up needing that place value. So I'm going to start with division by 512. I only have to do 4 divisions. So I've got 512, and it will divide 1725. How many times will 512 go into 1725? It will go in 3 times. What is 3 times 512? 15 what? 36. That sounds better. Yeah, 36. All right, let's divide again, but what will I divide by this time? 64. All right, so what is 1725 minus 1536? 189. How many times will 64 go into 189? Twice. What is 2 times 64? 128. Okay, what is 189 minus 128? 61? Okay. What am I going to divide by next? 8? How many times will 8 go into 61? What, 7 times 8? Okay, 61 minus 56? 5? Okay, and then I'm going to divide by 1, good, and it will go in 5 times. Do you see your solution? 3275 base 8. Okay. Here's what we're going to do. We're going to omit this from your homework because I want you to have group work time, okay? So I'll tell you which number that is. I'll write on the board for you and omit from your homework. Please get into groups, okay? We're not going to do this one. Yeah, we're done with 4-4 as much as we're going to do it. So go ahead and get into groups, and I'll tell you which number of problems that applies to you, although you probably could figure it out. And I'll just write it on the board. I think we've only got one person gone today. Who's Cancel's partner? Okay, Roxy, you can join another group, as long as it doesn't have 3 people in it already, okay? Any group of 5. That would work, we could do that. Yeah, that'll work. Okay. Okay, so the problems you don't have to do are 55 and 56. Everything else is, for lack of better terms, fair game.